Okay, we're going to talk about radicals. Radicals is this little square root thing over the top of the 36. Okay, so they call it square root. There's cube root, there's all kinds, and they're all kind of under the same umbrella called radicals. Now notice that 6 squared is 6 times 6, which is 36. Okay, see the relationship here? 6 times 6, square root of 36. So you can cancel both of them and you get 6, right? So I kind of use this method of doing simplification of radicals, okay? Where I cancel pairs, as many pairs as I can until there's no pairs left underneath the radical to simplify. So here we go. Let me get the notes wherever they are. There they are, right in front of me. Okay, so this is 64, and we know this is 8. 8 times 8 is a pair of 8s. If you cancel both of them, an 8 comes outside. Any 2 can, if you cancel 2, 1 can come outside. Okay, so now here's where we start having stuff left under the radical, because you know that radical 24 or square root of 24 is not going to be a perfect square like these up here. Okay, so the square root of 24, we start looking for factors or numbers that you multiply together to get 24, and there's several, right? So you got 6 times 4, okay? I can break the 6 down into 3 times 2. I'm looking for pairs, okay? And then I can break the 4 down into 2 times 2. So do I have a pair of 2s? Yes, I do. Don't forget the radical. I always wait until the end to do that. I don't know why. Anyway, so I cancel one pair of 2s. 1, 2 goes on the outside. And then do I have any more pairs? No. Okay, so I'm going to remultiply that back together and make it 6 and leave the 2 on the outside. Okay, and the decimal, you just punch it into a calculator, so I'm not worried about the decimal right now. Okay, so square root of 32 is an 8 times 4. Okay, it's also a 16 times 2. I'm going to do both ways. An 8, I would love to just go ahead and agree with you to go 2 times 2 times 2 for 8s, but there's going to be a 4 that'll come out of this. So I'm going to break down 4 times 2, and then still don't forget that 4. Bring it down, and then you're going to cancel a pair of 4s. A 4 comes out. Now, radical 2 doesn't have a pair or a partner to be able to clear out some more numbers. So my final answer is 4 radical 2. Okay, 16 is a perfect square that is bigger than 4, which I like. I can immediately go to 4 times 4, which in this one we did that anyway. But if you use big perfect squares and numbers like 196 or 200, it helps you so much to save time. But as long as you get it right, it doesn't matter. Okay, so 4 times 4, I got a pair of 4s. I'm going to cancel a 4. A 4 comes out, and once again, I get 4 radical 2. All right, so I could have said 2 times 2 times 2 times 2 times 2, because that's 32. Believe me, because 2 to the 5th power is 32. All right, I can cancel a pair of 2s, a 2 comes out. I can cancel another pair of 2s, a 2 comes out. Any number that comes out, it multiplies by the number that's on the outside. So that's 4 radical 2. Guess what? Same answer. Okay, number 5 here, we've got radical 50, which is 25 times 2. You could have used 10 and 5. Excuse me. So I pick 25 because I like 5 times 5. It's a perfect square, right? And I can be done right now. Bring a 5 out. Okay, cancel a pair of 5s. 1 5 comes out. All right. This one has a number on the outside already, and these did too. It just happened to be a 1. You understand that that's a 1 on the outside. Okay, so let's go back down here. So 3 radical 28. I'm going to break it down. 7 times 4. 3's on the outside. Don't forget him. 7 times 2 times 2. Okay, 3 on the outside. Is this thing working? Yeah, it is. Good. Scared me. Okay, so I cancel a 2. A 2 comes out. Anything that comes outside multiplies by the number that's out there. Usually a 1, but not this time. 2 times 3 is 6. Radical 7. So this is a simplified, it's kind of like simplifying fractions in a way, but it's just simplifying radicals. Okay, so same here. I mean, if there's a negative out here, it doesn't change anything. It's like negative 7 times whatever comes out. Okay, that's I would be letting you do that in class, so I'm going to just skip on. Okay, let's go 20 times 10. Okay, so I got a negative 7 out there, so 10 times 2 is 20, right? times 10. So you'll have a -7 on the outside. Cancel a pair of 10s. A 10 comes out. It's not 10 minus 7, but it's 10 times a -7. So that's -70 radical 2. Okay. Here, okay, you can always divide by 2, right? So what would that be? 49 times 4? Yeah. Okay. I'm trying to not do the obvious here because I know something you don't probably. Okay, so 49 times 4 is 7 times 7 times 2 times 2. There's a 12 out here. You cancel a pair of 7s, a 7 comes out. 2 times 2, you can cancel a pair of 2s, a 2 comes out. So 12 times 7 is 84 times 2 is 196. Oh gosh. Yeah, so 2 times, so that's 196. 84 times 2. What's 84 times 2? I'm having trouble. Working all day, I'm tired. Okay, so that's 8, 168. Okay, so this would be 168, my bad. Okay, everything disappeared from underneath the radical, so poof, the radical disappears. The thing that I knew is that this is actually a 14 times 14. Okay, so it's a perfect square. I could have canceled that and had a 14 come out, and 14 times 12 is 168. Okay, but if you don't recognize it, it's okay, you'll get there. Multiplying radicals, okay? Outside number times the outside number, then the inside number times the inside number, okay? So I'm going to skip over these and go to the next page. This is a 1. Well, let's do this one first. Outside times outside is 12. 3 times 4. Inside times inside is 40, but I'm not going to do that. I'm going to say 8 times 5 because I still have to simplify it. So you multiply outside times outside, inside times inside, then you simplify it. Okay, the 8 could be 4 times 2. Okay, you got a 12 on the outside. 2 times 2 times 2 times 5. Okay, and so I cancel a pair of 2s. So I got 24, no more pairs, so I just put those back together as 10. You don't go telling people you're 5 times 3 years old. All right, so 24 radical 10. All right, so you can actually multiply to get the area of a rectangle, right? Remember, it's base times height for area, right? So you can take these and multiply them together. So 4 radical 5 times 5 radical 9. So 4 times 5 is 20 on the outside. Inside times inside is 5 times 9, and then you just keep reducing. 5 times 3 times 3, right? Okay, and then you got a 20. Cancel the 3's, a 3 comes out, and you get 60 radical 5. And this is actually a perfect answer, okay? It's exact. Whereas if you punch it into a calculator, you'll get an approximation, okay? This is an exact answer. All right, square something. Whenever you square something, like say you had 3 squared, you're going to say that you're going to take that number and multiply it twice, right? 3 squared is 3 times 3, which is 9. Okay, so I can write this down twice, this big ugly looking thing. 3 radical 16 times 3 radical 16. I'm doing the same thing as I did here, 3 squared, right? So outside times outside is 9. Inside times inside works out nicely because it's going to be a perfect square. Cancel the 16s, a 16 comes out. Man, they are giving me a hard time. That's 54, 144, okay? 144. My brain's not working great. All right, so this one, 6 radical 36 times 6 radical 36, because you write it down twice and multiply, right? So outside times outside is 36. You got 36 times 36 on the inside. This is going to be worse than all of them. Okay, so 36 times 36 is, oh God. Okay, I used to know. 36, 3, 2, 16, 0, 18, 1, 10, 12, 96. Yeah, I knew that. Okay, 1296. Okay. So a square that has the length of a side that's 3 radical 4, then you'd multiply it by 3 radical 4, you know, because all the sides are the same. So if you're finding area, this times this, Anyway, you just do them like that. Okay, I need to get on to adding. Don't want this to take too awful long. Okay, adding, like 3x plus 2x is 5x, right? You add the numbers in front. They're called coefficients. Okay, and you add. The x doesn't change. It's not x squared unless you multiply. If you multiply x times x, you'd get x squared, but this is adding. We're seeing how many x's we have? Well, we got 3 and 2, so we got 5 of them. We got 5 x's. Well, these are like terms, just like x's are like terms, right? So you can add the numbers in front and not change the radical. You see what I did? Added the 3 and the 2, the radical 7 stayed the same, just like doing this. Okay. Now these two do not add. They are not like terms, so that's your answer. It's kind of like trying to say 3x plus 4y. It's still 3x plus 4y, right? Because they're not like terms. Okay, these are, and there's ones in front, so you can add them to get to radical 7. Yay, okay? Okay, 3 radical 7 minus 2 radical 7, you got like terms, so you have radical 7 as an answer. I could have put the 1 there, but you know, you don't have to have it there. This is the same thing, right? Okay, this one, they don't have like terms, but couldn't I simplify this one and see if radical 3 comes out of it? Okay, so let's do 4 times 3. Okay, 2 times 2 times 3, right? Okay, cancel the 2's. A 2 comes out. 2 times 3 is 6. Radical 3. Ooh, now I can add, because they're like terms. Both of them have a radical 3, right? So add the numbers in front. 6 plus 2 equals 8. Radical 3. Yay! All right, so it says find the exact perimeter of a rectangle whose width is 4 radical 5 and length is 5 radical 9. Okay, so basically we're going to take, you know, perimeters all the way around, right? We're going to take these two and add them together, right? Okay, they have like terms, so that's 8 radical 5, right? Plus these have like terms, so that would be 10 radical 9, and that's the answer. You can punch it into a calculator and get an approximation, but that's the exact answer. Okay, let's go back here. These are just, there's a 1 in front, okay? So 1 times 5 is 5. And then you've got the 6 times 4, and you just leave it like that so that you can start simplifying it. You don't want to write 24 and then start simplifying it after that. Okay, so 2 times 2 for the 4, right? And a lot of people like to use the little like tree thing that you're doing. And so you bring the 5 down, and then I've got a pair of 2's that I can bring out. 2 times the 5 is 10. And then no more pairs, so that's radical 6. Yay. Okay, and then there was a couple here. Basically, this is radical 10, because 1 times 1 is 1, right? So outside times outside is 1, so nothing changed. So it's inside times inside. Then you see if you can simplify, but you can't, because if I broke it down, it's 5 times 2, right? And then I see that radical 10 is the best I can do. Okay, then the last one here, there's a 1 on the outside. Outside times outside is 3, and then radical 2 is still just there. Okay, so 3 times the 1 on the outside became 3 here, so 3 radical 2. And it's not plus, it's multiplied. Okay, because the 1 that's in front is understood to be multiplied. Yay, we're done. You have a great day.